In this video, I want to talk about outer and inner measure. Now, the concept of outer and inner measure in the measure theory these are terms, they are concepts used to describe how we can approximate the size, typically length, area, volume, and so on of a set, especially when the set is complicated or not nicely measurable. So that is when we use the concept of outer and inner measure. Now, the outer measure itself is used to approximate the size or to cover the sets using simpler sets. What we normally do here is we take the infimum of the total measures of this cover. That is, when you intend to cover, to approximate the size of a set, you use, and it takes measurement from the outside. It approximates the set from the outside. That is for outer measure. So, for example, we have a set A, which is a set of n Euclidean space. And the outer measure, which is denoted as, this is a symbolic representation of outer measure, is written as, the outer measure is taking the infimum. That is, we have to take the infimum of the total cover. The infimum, that is, of the total cover. Let's say this is the cover, which is I moving from 1 to infinity, such that A is a subset of the cover. I is from 1 to infinity. And our cover is open. It is, the cover in this aspect should be countable or open. It's countable because you have the I moving from 1 to infinity, and it should be open too. Okay? The I to infinity. Alright, so in outer measure, we take the infimum. Taking the infimum means that we look for the smallest area of the cover we actually want to use. This UI is the cover itself. This is the set in question. Okay, so we cover it from the outside. We cover the set A from the outside. And let's quickly see how we can explain this intuitively. Let's show how this could be explained intuitively, and so that we understand better. Suppose we have a jelly blob, just like a toy, which is an object that you can place on the table. Let's say this is the what? This is the blob A. Let's call this A. The A in our A is a subset of Rn, so that is it. Now, we want to cover this particular object, jelly blob, placed on the table. And obviously, for us to do that, we use something like plastic material that is rectangular in shape, okay, to cover it up. These are the plastic materials, which are literally representing the simpler sets we want to use to cover our blob. Okay, now we have to make sure that one, it covers it perfectly. It can cover the edge of the block, no problem about that. Not block, table block, jelly blob, sorry about that. It's not blob, jelly blob. Now, what I'm saying in essence is that the materials needed to cover this must be, we are going to have a lot of plastic material needed. We are going to have different sizes of this material, but we need the one that will give us the smallest area. So the smallest area of the material is what we need to cover this particular object A. So that is why we always take the infimum, which is what? Which is the greatest lower band. That is for outer measure. Now, in the case of inner measure, the inner measure approximates the set from the what? From the inside. It approximates, that is, it covers the set from the inside, and making sure that the edges of the sets, the object it is covering, are not affected. Now, before I forget, the outer measure is used to, measure sets in the Carathéodory sense. It's used to know whether sets can be measured in the Carathéodory sense. Okay, please take note of that. And at the same time, it overestimates the size of the set to ensure that all parts of the sets are covered. I mean, the outer measure, it overestimates the size of the set to ensure that all parts of the set are covered. Now, like back to the inner measure I was talking about. I said the inner measure approximates the set from the inside, making sure that the supremum of the materials needed to measure the set is used rather. So now, let's assume we have this is the set in question. that we want to cover within. So this time around now, we need materials that could be used to cover it within, not without. Now, we could use a V-block now. Let's say we have a V-block like this, okay? Now we have to make sure that it does not affect the edges and it doesn't tamper with the edges of the material. This is the material, this is the set itself, A. Okay, these are the covers we are using. Okay, so let me shade it. This is the cover. Okay, this is the cover. So the sets will be measured within, that is from the inside. And one thing about it is why the outer measure overestimates the sets, this inner measure underestimates the set. You have to take note of the fact that the object you are using for measuring the size or approximate the size of this particular jelly blob, doesn't affect the structure or the shape of the. It shouldn't go outside the edges of the blob. It must be within, in such a way that it will be perfectly fitted. So in this case, we need the what? The supremum. That is, using that now, say the inner measure now is designated as this, is the supremum of, let's say, the total. Let's use Ki now. We need a compact set in the case of this one, Ki, which is a subset of A, such as that shows that, sorry about this, this will be the union of Ki, subset of A, such that Ui is compact. So the materials needed now, and our I is moving from 1 to what? Infinity. Okay, so it must be compact. It must be compact for the inner measure. Okay, so that is that about that. You could therefore differentiate clearly between outer and inner measure. You could differentiate clearly between outer and inner measure. As a recap, the outer measure measures the set from the outside, while the inner measure measures the set from the inside. In the case of outer measure, the infimum of the total measures of the covers is usually taken, while in the case of the inner measure, the supremum of the total measure of the cover is taken. In the case of outer measure, our covers are usually open and countable. But in the case of the inner measure, our covers are usually compact. So these are the distinct differences between outer and inner measure of a set in measure theory. So don't forget to click on the notification bell so that each time I upload a video, you'll be notified. Stay blessed and God bless you.